It's a few minutes later. As you can see, here is the old VCO block. It's just removed, and the rebuilt one's been installed. Turn my blinding light off there. Oh, actually, let me turn that on because I want to, or even fire it up. Let's see what our signals and everything look like. So the voltmeter up here is still turned on. Go ahead and turn the radio on. Down to channel 1. Ah, look at that. 3.49935. So, yeah, we don't even need to touch that. Now, actually, I might, because I have, I have this one I carry with me. It's always in my shirt pocket. This is a ultra super tight fit nose cores, perfect fit. But so there's a good sign right there. We have good. Our VCO voltage is correct. We didn't have the not normally listed, but like I say, I find it a handy test point because when that one's missing, it's usually an indication my VCO block is bad. I'll get on there, little guy. Ah! Look at that. We got a 17.55. Yeah, because we are on, channel 1. And let's see if we have output, which I usually just pick up easily. There's a jumper wire down here where there's a bunch of parts missing, which actually, tip just fell off. Gotta hate it when that happens. Okay. Move the light here a little bit. Anyhow, yeah, these parts weren't in here to start with. This jumper wire is normally here, and this would be your output from the synthesizer circuit, and there it is, 37.65. Yep. So let's see here. I don't need the scope anymore. Get switched over. Well, actually, let's try transmit. AM. Hey, we're transmitting now. Try sideband. This blasted light off again. Audio 1 2. Audio 1 2. Okay, we've got transmit. I'm going to assume we have reception. Flipped over to the antenna. Haha, we have static at least. Let's see if we have sideband. There we go. There's 38, lower sideband. Okay, that's what it was. Bad VCO block. So I'll have to throw this one in the needs to be rebuilt pile. Yeah, like I say, you can see how much of a pain in the neck these are. Like I said, I think I did a video on one of these, the ones that are housed in metal. I think I showed, like I say, the easiest way to do those, I find, to get the block out of this metal can is just go down, the grinder or a small cutoff wheel or something, score the outside at all 4 corners, and you can just peel, kind of open it up, peel it open like a flower, and pop the epoxy block out. Then you can get in there with your, Dremel tool or whatever your, I use my Pace desoldering machine has a built-in drive and hand piece, but like I say, I use a small ball mill, little carbide burr, but it's just a matter of going in here, and these have an electrolytic capacitor where the small green ones do not, so. It doesn't matter which part's bad. When I redo these, the two things I'm going to replace in here, because really it's the only two things that ever really go bad. It's either going to be the varactor diode or the electrolytic capacitor in these. Both of those are going to get replaced. So it doesn't matter which one's bad. I honestly don't care. I'm going to cut it open and both of those will get changed. So like I say, important thing is the radio now works. So I guess the really only thing I had to do left now is the transceiver alignment, and this one will be done. Well, other than cleaning the radio up, but that looks to have fixed our dead radio problem. Well, I thought I'd stick a little add-on onto this video. I actually went to stick the bad VCO block in with the rest of my bad ones, and saw I was up to 5 of them. So I thought, oh, what the hell? Now's as good a time ever to go ahead and tackle them. So I'm actually on the last one, which is the one that, this is the one that actually was replaced in the radio you just saw. So it's already been rebuilt. You can see where I've... Now this ceramic capacitor was replaced, and this does happen from time to time. Matter of fact, here is the original one that was there, and it's just a little bit depending. Sometimes it's fine, you don't need to replace it, but sometimes it gets over top of this electrolytic, which you're going to be replacing a little bit too far, and when you cut away at the epoxy to get in there, and you kind of pry this out to pull it out, what actually happens is it actually splits it in half. You can see it's still fine on one side, but the other side actually ripped. That was stuck to the epoxy on the back side. So, no biggie, just grind that away and then stick a new one in there. We're already in here putting 2 new parts in there. So, there's the electrolytic capacitor. And if you look down in there, that is not a transistor. That is the replacement varactor diode down in there. And then this is the one also, the some nitwit had cracked the core, so that's been replaced. Now to do that, you actually it's still sitting here. Here's the piece of epoxy that originally, get it in the right orientation here, that used to sit right there. But that hole was usually not there. That hole has to be bored out. The circuit board is solid on the underside there. It's not hard to figure out where to bore, because these 5 terminals are basically the outside edge of that coil. So just mark the center. I just take a carbide burr that is also, to focus on that or not, but it actually has teeth. Kind of hard to see, but it actually has teeth. It was in focus for a split second. In any case, it has cutters built into the end of it. Maybe I can get one on the block here. Oh, for Pete's sakes. Just don't want to focus on this little tiny stuff. There we go, that one on the far right bottom row. That's exactly what's in the chuck right now. Like I say, I just use that one and bore a hole straight down through. Then I can get in with a proper tool, because like I say, matter of fact, here is the old one. See, there was the top edge. But like I say, has the slot in the bottom. So that's already been replaced. And any good radio tech worth his salt, excuse me, breathing all this damn fiberglass dust in. But any radio tech worth his salt, anytime he scraps a radio out, should be saving all of his cores out of his transformers. So as you can see, I've got boxes, and this is 3 of about a dozen, different boxes that I have. But so these take the violet cores. So that's these little guys right here. Same length, same color, so they're the same permeability. So it has a new core installed. It's not cracked. And another little tip I can give you, when you put that back in, to try and prevent nitwits from breaking them. Now the centers of these transformers, it's a plastic tube with like 3 or 4 little bumps of plastic that stick out. And then when they put the core in it, that kind of cuts the threads into that plastic. But it can be a little bit tight, and of course these things will be, not adjusted for decades possibly. and it can kind of get stuck. So what I like to do is, before I put the new core back in, and that's of course what I seal all my transformers with whenever I'm done doing an alignment on them, is beeswax. In fact, if you can see in there, it even says bees. But I buy these little bars of beeswax on eBay. Where else? They're for cosmetic. Like I say, they're, it's very soft, pliable wax. Don't use candle wax. That stuff's hard as a damn rock. That's why I like using this. They use this to make lip balm and cosmetics and whatnot. So it's a very high grade. But in any case, what I do is I take a tiny little bit and kind of shove it down in the hole and kind of smush it around, and then I coat the outside of that ferrite core with a little bit of wax. It acts as a little bit of a lubricant, so it's a lot easier to turn. And the whole idea being that, decades down the road, hopefully that thing won't get stuck. Like I say, the main problem I think is people use things like this to try and, that won't fit in that slot, it's too big, but they use a metal screwdriver. Problem with a metal screwdriver is you're only going to make 2 tiny contact points on the inside of that slot when you put that screwdriver in there. That's going to be the 2 opposing edges. Well, those things are as sharp as a knife edge, and that's exactly what happens when you use a screwdriver in one of these cores. It cracks it. And the same goes for, you'll see me using these all the time, these ceramic adjusters. I got 3 of them here in my shirt pocket, 3 different sizes. My yellow, red, and green get used all the time, okay? But there's no difference here. Now, these are fine for adjusting stuff because they're non-inductive, but the problem is these also can crack these cores. Now, if they're loose, 90% of the majority of adjustments, I don't do these with them, but the majority of the transformer cores you do in a radio, this one here gets used and it's just fine. If I stick it in and the core turns very easily, I don't have a problem using this. If it starts to bind, I stop. Proceed no farther. Pull out a proper, alignment tool. One of these, I've got hundreds and hundreds and hundreds of the damn things, every flavor and everything you can think of. But, use a proper alignment tool. Because the whole idea here is, and you can see this, how short this is. It actually used to be about that long originally. Over the years, that tip will break off. But that's the whole idea. Either that rounds off or it breaks, because it's softer than that, so it can deform. Well, this breaking off's no problem. The tip of that breaks off. I just use, matter of fact, that alpha cutter right there, and I just shave down a little bit farther and make myself a new tip. So, a lot easier to fix this piece of plastic, and when this wears out, I throw it in a trash can and dust the next one off out of the alignment toolkit and, start from scratch again. Well, like I say, you break that, the only way to get the core out of one of these is to cut the can open, remove the block, cut all the epoxy away, bore a hole through it so you can get an alignment tool down in from this side to force it out the other, back out the top side. So yeah, pain in the ass. Just do yourself a favor. Don't use the wrong tool. These damn things are cheap, man, and they still make them. GC Electronics still has a fantastic selection of alignment tools. So there you go. There's just thought I'd show the actual block. Like I say, I had to do a little bit more to this one because, like I say, I had to change this ceramic capacitor here because it got stuck behind this aluminum electrolytic, and when I was taking it out, it just basically split in half. But no biggie. We're already in there. So there's what she looks like. Now what I'll do is I test this. I'll stick this in a breadboard and actually test it to make sure. Because the last thing I want to do is put this whole damn thing back together. And I actually solder the edges of these once I close the can up. I run a bead of solder down all 4 corners so it's sealed again. But I'll actually stick this in a breadboard first, make sure this thing works. Once I verify that it actually works, I'll actually... Now, I don't use epoxy again, so, 20, 30, 40 years from now, somebody else needs to get in here to service this thing, especially this electrolytic capacitor. What I use is potting silicone, which is very easy to remove. It just kind of crumbles. It's orange in color. So, like I said, that's what I use. the epoxy potted was a good idea because it does keep these extremely temperature stable. So, that's one big advantage of the Cybernets was stuff like this. That does help to prevent frequency drift. Once it warms up, these help, variations in temperature inside the radio cabinet don't affect the frequency as much as a lot of other radios, and this is why, because once this block reaches operating temperature, it tends to, it's almost, now it's not a crystal oven, but it kind of, there's resistors in there, so it's generating a little bit of its own heat, so it helps to keep it stable. So once verify it's done, like I say, fill all this stuff that I've removed in here with the potting silicone, and then that helps to, keep it the same way. Keep the, thermal stability properties just like they were. So there you go. Another VCO, or Cybernet VCO block saved from the scrapyard.